Welcome to The Explainer. Today, we're diving into something that's hiding in plain sight in pretty much every factory, a massive, untapped profit center. And believe it or not, it's hiding in your energy bill. Okay, let's just jump right in with a question that should get every manager's attention. What if you could boost your profitability by, say, 20% without having to find a single new customer or sell one more product? Yeah, it sounds a little too good to be true, but stick with me. It's absolutely possible. Here's the secret. It's all about a powerful but often overlooked economic truth. For your average plastics manufacturer, every single dollar you save on energy has the same impact on your bottom line as generating $10 to $20 in new sales. Let that sink in. It's a huge multiplier. So you're probably thinking, if the payoff is that big, why isn't every company all over this? Well, the truth is, a lot of them have tried, and most of them have failed. Why? Because they see a high energy bill and just try to treat this symptom, not the actual disease. Without a real systematic method, these efforts are pretty much dead in the water. So how do we do it right? How do we build a system that actually works? Well, it all starts by creating what you could call an energy fingerprint for your factory. And to do that, we only need to focus on two key metrics that are going to guide everything we do. First things first, we have to stop looking at the factory's energy use as just one big scary number on a bill. Instead, we need to break it down into what we call energy cost centers. This can be an entire production line, or you can get as granular as a single machine. This lets us zoom in on where the energy is really going. Second, once we have our cost centers, we need a scorecard for each one. That's where specific energy consumption, or SEC, comes in. It's a really simple ratio. How many kilowatt hours did you use for every kilogram of good product you made? The goal from here on out is simple. Get that number as low as you possibly can. And this is where it gets really, really cool. As Dr. Estrada points out here, when you start chasing energy efficiency, you almost accidentally find production efficiency along the way. You're not just cutting your electricity bill, you end up making more stuff faster. And honestly, that's where the real money is often hiding. Okay, so we've got our metrics. We know what to measure. Now, how do we actually find the problems? For that, we use this really powerful framework called the energy gaps method. It's all about systematically peeling back the layers of your operation to find those hidden pockets of waste. Think of it like this. Instead of one big, vague problem called inefficiency, this method slices it into specific, solvable chunks. You've got the quality gap. That's all the energy you burned making bad parts. Then there's the production gap, energy wasted when a machine is just sitting there humming away but not making anything. The process gap comes from running with bad settings. And finally, the technology gap. That's the price you pay for using older, clunkier equipment. And the beauty of this whole thing? It gives you a crystal clear roadmap. You just look at which gap is the biggest. If it's the quality gap, you know you need to focus on reducing scrap. If the production gap is massive, you need to work on making your changeovers faster. It takes the vague goal of being more efficient and turns it into a targeted, step-by-step action plan. Now, this whole diagnostic process does more than just give you a to-do list. It actually generates a super powerful visual tool, a literal map that tells you exactly where to go to get the biggest bang for your buck. But hold on, before we can read this map, we have to get one really critical distinction straight. Energy efficiency is not the same thing as energy performance. Efficiency is absolute, like miles per gallon. Performance, on the other hand, is relative. It asks, how is this specific production run doing compared to the average? You can actually be efficient, but still be a poor performer. And you can be inefficient, but a great performer. It's a subtle but crucial difference. So think of this map as an EKG for your factory's health. Every single dot on this chart is a specific production run, a specific mold, or a material. It's plotted with its efficiency on one axis and its performance against the average on the other. And just like a doctor looking at an EKG, you can immediately spot the irregularities and the problem area. The map is basically split into 4 zones, and each one tells you exactly what to do. The dots that land in this pink area, those are your problem children. They have bad efficiency and bad performance. Fixing them is going to take some real engineering work. But then, look over at the yellow area. These are your easy wins. They're actually performing well, but they're inefficient. Why? Usually, it's just because the production runs are too small. The fix is dead simple. Just make bigger batches. Now, over in the green zone, you've got your all-stars. These are the runs with great efficiency and great performance. Your job here isn't to fix them, it's to figure out what makes them so good and then copy it everywhere else. And finally, that little blue area, those are your don't worry yet points. They're not an immediate priority. This map just gives your team instant, undeniable clarity on where to spend their time. Okay, so this all sounds fantastic in theory, right? But what does it actually look like in the real world? Let's check out the results from a factory that put this exact methodology to the test. And get this, the analysis wasn't even for the whole factory. They focused on just one single injection molding machine. Over 5 months, they tracked every job that ran on it. We're talking 43 different molds and over 100 different products. So what did they find? The map immediately gave them these incredibly clear, actionable insights. It basically screamed at them that any mold producing less than 18 kilograms an hour was a massive energy drain. It even showed them a clear financial break-even point. Any job smaller than 950 kilos was losing them money from an energy standpoint. Suddenly, they had hard data to make tough decisions about which jobs to keep, which molds to redesign, and which ones to maybe even outsource. And the potential payoff? It was absolutely staggering. Just by targeting the problem areas that the map pointed out, the analysis showed they could cut energy consumption by 24%. And on top of that, they could boost productivity by an almost identical 23%. And that 23% productivity gain wasn't just some abstract number. It translated to 1,650 additional hours of productive time on that one machine every single year. That's like getting months of extra production capacity for free from a machine you already own. So what this all proves is that the real answers aren't just about looking at your energy bill and wincing. They're about diagnosing it, about using the right framework to find the quality gaps, the production gaps, and the process gaps, where all this profit is hiding. Which really just leaves one question. Where are the biggest hidden profit centers in your factory?